Hello everyone, welcome back. So today let us start with digital signatures. So basically a digital signature scheme can be described by two algorithms. First is signature, second is verification. Signature, this takes as input a message. This takes as input a message and private key and returns a signature on the message. And returns on message. And what is verification? So this takes as input the message signature and public key and returns true or false. Depending on whether the signature was valid, correct, corresponding to the message or not. Message or not. So if we see formal definition, then let me start giving a formal definition. Formally, a digital signature can be defined by 5 tuple. We call it as P sigma K S V. Okay, where P is a finite set of possible message. Finite set of possible message. Sigma is a finite set of possible signature. K finite set of possible keys. We call it as key space. Okay, and what happens for each key? K belongs to K, where there is a signing algorithm. There is a signing algorithm. We call the notation signature with the key, signature key belongs to S, and corresponding verification. Corresponding verification algorithm. So actually the signature algorithm takes plain text and give a signature, and verification algorithm take the plain text and signature and gives the true or false. Okay, in short, what does the verification t? It will be say xy is it true if y is the signature. Y is the signature of x. For every x belongs to P and every signature Y belongs to Q. So this is what happens. Let me just talk about digital signature scheme. How does a scheme here look like? Usually a cryptographic design, the digital signature scheme are formally structured with the following algorithm. The first one is params. If you put the setup lambda is the security parameter, it will give the parameters. We call it as params. This is an algorithm which takes as input a security parameter, which takes as input a security parameter, lambda, and outputs the public parameter param. It has params. So with the help of these params, the key generation algorithm carried. So key generation is what? By inputting these parameters, you will get two keys, that is secret key and verification key. Call it SK and VK. What is this? It is an algorithm which takes as input public parameter, say param, and output a signing key, which is private or secret, denoted as by SK, and verification key, which is actually public key, denoted by VK. Okay, now how the signing algorithm takes place. if you the signing algorithm, that is signature, you will input the message, you will input the secret key and the parameters, then you will then get this sigma is the signature on that message. This is usually a probabilistic algorithm. Run by signer. That takes as input the message, M to be signed, signing key, we call it as key, and public parameter param. To generate a signature. Delta. So this delta is generated by giving the message and signing key, that is secret key, and then param. And for verification, what are the things we have to give? Verification value will be B. Verification key, message, and sigma. You have to input the verification key, that is publicly available, parameters, and then message and the signature which you got. Deterministic algorithm. Run by verifier. That takes as input the public parameter, params, signer's public key, public key, that is a verification key VK, the message M, and the signature sigma, and returns a bit B, which is 1 if the if the signature is valid, and 0 if invalid. This is the deterministic algorithm. That means every time it will give the correct value, either 1 or 0, whereas in this case this is probabilistic. That means for the same message I can get the different signature. Okay, so just let me just give you a difference. What is the difference between uh, common signature and the digital signature? and here let me type conventional. See, the conventional signature is included in the document. That means it is the part of the document, whereas digital signature is not included in the document. Has to be sent as a separate document. This is the first point. See, digital signature of a message is intimately connected with the message, and for different message it is different, one-to-one relation. Whereas handwritten signature is not dependent on the message, but only see digital signature of a message is intimately connected with the message, and for different message I'll be having different signatures. It is different. This is, you can say, one-to-one relation. That means for every message I will be having different signature, whereas in handwritten signature, that is conventional signature, it is not dependent to the message. But only adjoined to the message. And always remains same for different messages. This is one-to-many function. Okay, so why do we need digital signature? See, digital signature can give us it can give source authentication, data integrity, and non-repudiation. Non-repudiation means what? If someone has signed on the document, he cannot deny. Whereas in conventional signature, this can happen. That people can deny that I have not signed. There is no proof. So, what are the goals of attacker in the case of digital signature? Attack goals of an adversary of a digital signature. In cryptography, actually, we study the attacker goals of an adversary of register in the following views. First, we consider adversary's view of the attack. Say, yeah, adversary, let me denote it by A. This is the A. Adversary's view. First, he can do either total break. Total break means what? Either the adversary is able to compute the private key of the signer, or he can derive an efficient algorithm or equivalent to signing equivalent signing algorithm. This adversary is able to compute the private key for the signer, or adversary can derive an efficient algorithm equivalent to signing algorithm. This is called total break because no security left. Next is universal forgery. In this case, adversary attempts to forge a digital signature without having the private key of signer. That means what? He has some message, he want to have the signature of some signer, but without having that private key, he is able to get that. He will attempt to forge. Okay. This is universal forgery. Next is selective forgery. So here also adversary can generate a valid signature for a given public key for a particular message chosen prior to the attack. Message for a particular message chosen prior to the attack. This is known as target message forgery. Call it as target message forgery. Okay. Another is existential forgery. So in that case, the adversary A can forge a signature for at least one message. In other words, if you see that adversary can output at least one message signature pair such that sigma is valid signature on that message. So there exists a message whose signature he is able to find. So that's why it is called existential forgery. Selective means what? He can select a message and then attack and then get the signature on that. Universal forgery, that he can generate the digital signature without having the private key of the signer. The first one was he will get the private key of the signer, that is total break. Second is without private key he is getting the signature, that is universal forgery. And then selective and existential. So these attacks can be classified in the following category depending on the access provided to the adversary. These attacks can be classified in the following categories depending upon the access provided to the adversary. The first is key only attack. In this attack, an adversary knows only the signer's public key. Only the signer's public key. This attack is also known as public key only attack or passive attack. Passive attack or public key only attack. Okay. Then next is message attack. Here an adversary is given access to the signing oracle. Access to the signing oracle. Corresponding to certain messages. So the message attack can be further divided into three forms actually. The first is known message attack. Chosen message attack. And adaptive chosen message attack. See, known message attack, that is an adversary can obtain a valid signature for a message known to him. Known to him. Okay. Chosen message attack, an adversary can generate valid signature for the message from a chosen list of message. for the messages from a chosen list of messages. And in the case of adaptive chosen message attack, an adversary can generate valid signatures for the chosen messages depending upon previously obtained pairs. Message signature pairs. See, after the proposal of identity-based cryptography, digital signatures are designed and studied extensively on ID-based setting also. For ID-based setting, we also study the following attack, that is chosen ID attack. Chosen ID attack. What does that mean? An adversary can obtain valid signatures for a chosen list of identities. And then adaptive what is this? An adversary can adversary is given signing oracle, access to the signing oracle for any identity chosen adaptively. So in the both the cases, it is understood that the identities submitted to the signing oracle are other than the target identity on which the adversary want to forge the signature. The above definition implies that a secure signature should be robust against the adaptive chosen message attack. Okay, thank you.